Space, often perceived as a vast empty void, secretly harbors a surprising, pervasive stickiness. This cosmic adhesion, far more persistent than any terrestrial grip, poses unique challenges for exploration. Imagine a microscopic version of Velcro, but one that operates not with hooks and loops, but with atomic bonds. This invisible force explains why fine lunar dust, for instance, clings tenaciously to everything it touches. Astronauts discovered this firsthand during Apollo missions, struggling with dust that infiltrated every piece of equipment. Lunar regolith, a powdery mix of rock fragments, possesses an incredibly abrasive and adhesive nature. These tiny, jagged particles can abrade seals, clog mechanisms, and even obscure optical sensors with remarkable efficiency. Understanding this universal stickiness becomes paramount for designing robust spacecraft and durable surface operations. Without proper mitigation, this pervasive dust threatens mission longevity and astronaut safety on other worlds. Scientists realized early on that space environments amplify forces usually negligible on Earth. This phenomenon is not limited to the Moon, extending to asteroids, comets, and even interstellar particles. The sheer ubiquitousness of this cosmic Velcro demands innovative solutions for future deep space endeavors. So, why does space dust behave like an inescapable, ultrafine adhesive? The vacuum of space plays a crucial role, removing the insulating layer of air and moisture found on Earth. Without this buffer, surfaces and particles can directly interact at an atomic level, forming strong bonds. This direct contact allows for a process called cold welding, where two clean metal surfaces spontaneously fuse together. While not always full welding, the principle applies to microscopic dust particles, creating powerful adhesive forces. Furthermore, exposure to solar radiation and cosmic rays imparts an electrostatic charge to lunar dust grains. These charges cause the dust to levitate and drift, creating a dynamic, electrically charged cloud around celestial bodies. This levitating dust then adheres more aggressively to uncharged or oppositely charged surfaces, like an invisible magnet. Imagine tiny, static-charged burrs relentlessly clinging to every available fabric and surface. This effect was vividly demonstrated during Apollo missions, where dust accumulated in unexpected places inside the lander. Astronauts reported significant wear on their suits, visors, and tools from the abrasive nature of this sticky dust. One astronaut even described the lunar dust as smelling like spent gunpowder, a testament to its unique composition. But that's not the strangest part about cosmic adhesion. Its influence extends far beyond mere nuisance. Scientists discovered that this same adhesive mechanism helps form larger aggregates of dust in protoplanetary disks. Tiny grains gently collide and stick together, slowly building up into pebbles, then boulders, then planetesimals. This cosmic Velcro is therefore fundamental to the very birth of planets and entire solar systems. Without this natural sticking power, the universe might remain a diffuse cloud of individual particles forever. Wait until you hear how researchers are now trying to harness this very same sticky principle. Engineers are developing novel materials that actively repel dust, mimicking the self-cleaning properties of some leaves. Other teams explore electrostatic fields to sweep dust away from sensitive equipment, essentially creating an invisible broom. Researchers also investigate gecko-like adhesives for robotic grippers, designed to cling and release on command in vacuum. These advanced materials could revolutionize how robots interact with surfaces on asteroids or other airless worlds. One promising concept involves magnetic fields to manipulate iron-rich dust, effectively separating it from valuable resources. This technology could enable cleaner operations, prolonging the lifespan of crucial machinery on distant outposts. The challenge lies in creating solutions that remain effective despite extreme temperature swings and constant radiation exposure. And then something unexpected happened regarding how we think about natural adhesion in space. Recent studies suggest even organic molecules can form surprisingly strong bonds in interstellar clouds. This molecular Velcro might contribute to the formation of complex organic compounds, precursors to life itself. The universe truly uses adhesion at every scale, from dust motes to the building blocks of existence. This intricate dance of attraction and repulsion shapes cosmic evolution in profound and unexpected ways. Understanding this cosmic Velcro profoundly impacts the future of human space exploration. Engineers can now design spacecraft and habitats with surfaces specifically engineered to resist dust accumulation. This knowledge is vital for developing long-duration missions to the Moon, Mars, and beyond, ensuring equipment reliability. Imagine solar panels that remain crystal clear and efficient for decades, despite constant bombardment by abrasive dust. Astronauts will benefit from advanced spacesuits that shed dust easily, preventing contamination and wear on crucial life support. This adherence phenomenon also guides the search for water ice on airless bodies like the Moon's poles. Dust particles might act as tiny shields, protecting ice from sublimation by forming an insulating, adhesive layer. Effectively, the Velcro holds the water in place, preserving a precious resource for future explorers. Furthermore, insights into dust aggregation inform strategies for asteroid mining, helping to process regolith more efficiently. Extracting valuable minerals from sticky, abrasive asteroid material requires specialized tools and handling techniques. This means better resource utilization, reducing the need to launch supplies from Earth, making space travel more sustainable. The very definition of clean in space is being redefined, moving beyond sterility to managing particulate adhesion. This shift ensures that our machines and our bodies can thrive in environments previously deemed too harsh. Ultimately, mastering the art of cosmic adhesion is key to unlocking humanity's permanent presence among the stars. The smallest particles hold the biggest secrets to our expansion into the cosmos. The seemingly simple concept of Velcro therefore reveals profound truths about the universe's fundamental workings and future exploration. If you found this cosmic stickiness fascinating, subscribe for more incredible stories from the frontiers of science. Let me know in the comments what other hidden forces of the universe you find most intriguing.